Now let's take few questions using these formulae. You have that if y is equal to sine inverse of x, then you got dy dx is derivative of sine inverse x, and you got it was 1 upon 1 minus root of 1 minus x square from this list of formulas you can see. So based on that, now we can see more applications. As an example, if suppose you have y is equal to sine inverse of say x cube, simple application, chain rule, you will say this dy dx will be equal to derivative of this, but in place of x it is something else, x cube. So we will say differentiate that. This is the formula, this is the shape of the formula. You can say root of 1 upon root of 1 minus x square. But here in this problem it is not x, it is something else. So you write it down here, whatever it was. In place of x it is something else. So whenever it is like that, multiply by the derivative of this expression which is in place of x. What do you call it? Chain rule. Okay. So this will become now 1 upon root of 1 minus x cube and its square. So you got it x to power 6 multiplied by d dx of x cube, which will be 3x square. This process of differentiation is complete now. Simply you can write 3x square upon root of 1 minus x to power 6. This is your answer. You can take few more. Now I can erase this part and say as an example, y is equal to tan inverse of say e to power x, for example, tan inverse of e to power x. So you will say dy dx will be equal to 1 upon 1 plus x square. Here is the pattern. d dx of tan inverse x is 1 upon 1 plus x square. So 1 upon 1 plus x square, but here it is not x, it is something else. You write it down whatever it is, e to power x, and in that case you will have to multiply by the differential coefficient of that value which is in place of x. You will say multiply by this. Is that okay? Then you just simplify. The process of differentiation is complete. You will say e to power, and when it is power and another power, exponent and another exponent, you just multiply them. You get 2 into x, e to power 2 into x. And d dx of e to power x, as you know, d dx of e to power x is also d dx itself. So finally you got the answer as e to power x divided by 1 plus e to power 2x. That's your answer. Okay. Shall I erase it now? Yes. I am erasing this formula also. I assume that you know them, and whenever required we can write them, use them. Now I am taking another example. Y is equal to tan inverse 1 minus cos x upon 1 plus cos x. 1 minus cos x upon 1 plus cos x. In this case, what you have to learn is that first of all we will simplify this expression and then go for differentiation. Okay? We will write it as tan inverse x, tan inverse of not x, tan inverse of this value, and we have to simplify this using your basic trigonometry. Use your cos 2a formula. What is that formula for cos 2a? We have it cos 2a as 1 minus 2 sine square a, as well as one more form is 2 cos square a minus 1, 2 cos square a minus 1. We have the option using this formula or using this formula. What we do, we have to choose them carefully. Choose in such a way that this 1 cancels out after substitution. So in the denominator I am writing first of all, because it's with the positive sign, it's easier to understand. Cos of x can be written here 2 cos square. Now see, when it is cos 2a, you have 2 cos square a minus 1. Just try to relate. When this was 2a, this is a. If it is say 100 degree, it will be 50 degree. If it is 10 degree, it will become 5 degree. If it is x, it will become half of that. It will become now 2 cos square x upon 2 minus 1. We have used this formula 2 cos square x upon 2 minus 1, because this is half of this angle as it was half of this angle. And similarly now 1 minus, and in the numerator we cannot use this one. See it carefully, because if you use the same formula, you write here 1 minus 2 cos square a minus 1, this minus outside and this minus sign will convert into plus sign. It won't cancel. So what shall you do? Use the other one. 1 minus 2 sine square, and again half the angle. It was 2a and a, it is x, so it will make it x upon 2. Okay, is that okay? You will write tan inverse of, inside this expression, it is 1 minus 1, and minus will make it a plus sign. So 2 sine square x upon 2, and in the denominator it already positive and negative sign will cancel out. Therefore, you will write here 2 cos square x upon 2 after cancellation of this 1. Then this 1 and 1 also cancels out, and once they are cancelled out, you can cancel this 2 also, right? So you can say you got it as tan inverse, and inside this square root sign you got sine square of an angle upon cos square of the same angle, that is tan square of the same angle. You can say tan square of the same angle. You got tan inverse of root of tan, square root of tan square x by 2. Simply you can say this is tan inverse of tan of x by 2, and in the particular domain tan inverse of tan will simply remove them, and you got the simplified form as x upon 2. So far we have not done any differentiation, it's only the simplification process. Y is equal to tan inverse of this expression is simplified to this much, and now we have to differentiate. This is y. Either you say this is the value of y which you have to differentiate, or you say equivalent value. Simply you will say dy. Now you will differentiate, you will say differentiate with respect to x. You got it, dy dx is equal to simply the coefficient, like ddx of 2x is 2, ddx of 3x is 3, ddx of x upon 2, or ddx of half x, you can say, will be half, that is 1 upon 2. Is this okay? Shall we take next? Sometimes, I erase it now. Sometimes your expression is not as simple or as direct as it was. This expression, another question I am taking cot inverse of, once again this is the square root sign, and inside the root it is 1 minus sine and 1 plus sine of a certain angle. The point is, this is not the value is not cos, because with cos you have the benefit that cos 2 is 2 cos square x by 2, 2 cos square x is 2 cos cos 2x is 2 cos square x minus 1. In this case it is sine. The question is given in this form. We know that sin x can be converted into cos, because we know that if it was cos, then cancellation of this 1 is easy. That guides us that we should convert this sine into cos. Recall in your class 9, I think you used the 90 minus theta formulae, complementary angles. So in place of sin x, let's say this was y is equal to this. This is your example to be differentiated, this expression to be differentiated there. We are trying to simplify. This is cot inverse of, this is 1 minus and this is 1 plus, and instead of writing it as sin x, we will write it as cos of 90, that is pi by 2 minus s. Remember, in calculus you cannot use degrees, always in radians you have to use. So we will write cos 90 degree minus theta, or cos of pi by 2 radians minus x. So in place of sin x, we have converted it as cos of pi by 2 minus x same way in the denominator, cos of pi by 2 minus x. We know that cos pi by 2 minus x, that is cos 90 degree minus x, is sin x as it was, and similarly for the numerator. So this is the main work. Cot inverse. Now convert into half angles as we did in the previous question. You will say 1 minus and 1 minus 2 sine square of what angle? Half of this. Half of this. Half of this angle will be half of pi by 2 is pi by 4 minus half of x is x upon 2. Is that okay? And this is now 1 plus as it was, and then instead of writing cos 90 minus theta or cos of some angle, we will convert as 2 cos square half the angle minus 1. So cos of 2a, 2 cos square x minus 1, so you will say 2 cos square half of this. So no need of this bracket now because it's positive sign outside. So you will say half of the angle pi by 2 is pi by 4, half of this is x by 2 minus 1, right? 2 cos square x minus 1 form and 1 minus 2 sin square x form. So it was like this. This 1 cancels here, and then you get it as cot inverse of root of 1 minus 1 plus, it will change and make it plus sign 2 sine square of pi by 4 minus x by 2, and in the denominator it is 2 cos square and the angle is pi by 4 minus x by 2 as it was there in the numerator also. This 1 cancels from here, and then after that 2 will cancel, and you get it as cot inverse sin square upon cos square is tan square of an angle because the angles are same. The square root of tan square will make it only tan, and tan of the angle pi by 4 minus x by 2. Now this is a point where we will learn one more thing, how to convert that tan into cot so that this cancellation takes place. What shall we do? We will write here this same y can be written as cot inverse as it is, and in place of that tan you can say cot of 90 degree minus the same angle, or cot of pi by 2 minus the same thing. So cot inverse of cot, and here you can say pi by 2 minus, because cot 90 minus theta was tan theta as it was, so 90 minus the angle, your angle was pi by 4 minus x by 2. This one. What we have done? We are trying to convert this tan into cot so that this is simplified, and inverse will also be removed. Cot inverse of cot something, this will be removed. Now you got it only pi by 2 minus pi by 4, minus and minus makes it a plus sign x by 2. You get it now. LCM for these two parts only I am writing. So 2 2s are, so 2 pi minus pi, that is pi plus x by 2. So pi by 2 minus pi by 4 is simplified to pi by 4 plus x by 2. This is your simplified value of this y. So you had to differentiate this, you can differentiate this as well. dy dx is equal to ddx of pi by 4, which is a constant, it will become just 0, and ddx of x upon 2 or 1 upon 2x, only 1 upon 2, and therefore you got finally, okay, that's it.